Have you ever stopped to think about how we connect the word dog to a picture of one? It seems so simple for us, right? But for an AI, that's one of the toughest problems out there. Well, today we're going to dive into a pretty groundbreaking model that learns to see the world not from millions of hand-labeled images, but from the way we actually talk about them online.
So let me just ask you this. Can an AI look at a picture of something it has absolutely zero training data for and still tell you what it is? I mean, it sounds kind of like magic, but the answer is a fascinating and resounding yes.
This AI can do it. This is a model from OpenAI called Clip, and it can identify this puppy without ever being specifically trained on what a puppy even is. It's a concept called zero-shot learning, and honestly, it's a massive leap forward. So let's break down exactly how it pulls this off.
All right, here's our game plan. First, we'll unpack the big vision problem AI has been stuck on. Then, we'll see how learning from language completely changes the game. We'll take a peek inside the Clip model itself, put it through its paces, and ask if this really creates a more robust AI, before we zoom out and look at the bigger picture.
So, first up, AI's vision problem. The whole issue really boils down to the limits of labels. You see, most of the top-tier computer vision systems out there are trained on a fixed set of categories. They can spot a cat or a car because they've seen thousands and thousands of examples labeled cat or car. But that whole approach is, well, it's kind of a dead end. Anytime you want to recognize something new, you have to build a whole new labeled dataset. The real goal, the dream, has always been to build an AI that's flexible enough to get any visual concept you throw at it, not just the ones on its cheat sheet.
Think of it like this. A traditional AI is like a student who has just memorized the answers for a very specific multiple-choice test. Yeah, they'll ace that test, no problem. But the second you ask them an open-ended question or something just a little bit different, they're totally lost. They can't generalize what they know. So, how do we get past that? How do we break out of that box? Well, that brings us to the core idea behind Clip, learning from language. And this just opens up a ridiculously bigger source of supervision. And when I say bigger, I mean 400 million. The team at OpenAI built a new dataset by scraping 400 million image and text pairs from all over the internet. And get this, we're not talking about 400 million perfectly labeled images. We're talking about 400 million images with their original, raw, and often pretty messy, text captions.
And this right here is the breakthrough moment. Instead of spoon-feeding an AI these perfectly curated labels, what if you just let it learn from the enormous, chaotic amount of text that already lives alongside images online? It basically learns to connect words and pictures just by observing how we do it naturally, all across the web.
Okay, so how does this actually work under the hood? What's going on inside the model? Well, at its heart, you can think of Clip's training process as one giant matching game.
It's really a two-stage process. First, during what's called pre-training, the model looks at a massive batch of images and their text captions. Its one and only job is to figure out which image goes with which piece of text. It's literally just a huge game of matchup. Then, once it's trained, you can give it a totally new task. You just give it the text for your new categories, say dog or cat, and when you show it a new image, Clip will tell you which text description is the best fit.
And that ability, right there, is what we call zero-shot transfer. It's the model's power to do a task, like classifying a whole new set of images, without ever having seen a single training example for that specific job. It's just using everything it learned from that giant internet-scale matching game.
So, okay, the theory sounds brilliant, right? But the real question is, how well does it actually perform in the wild? Let's take a look at the results.
And the results are, well, they're pretty incredible. When you put it up against a strong, fully supervised model like ResNet 50, zero-shot Clip is wildly competitive. Across 27 different image datasets, it actually beat the specialized model on 16 of them. And just remember, Clip did this without any specific training for these tasks. None. To really hammer this home, on the super famous ImageNet benchmark, zero-shot Clip got the same accuracy as a ResNet 50 model. Now, here's the kicker. The ResNet 50 was trained on ImageNet's 1.28 million labeled examples. Clip used exactly 0 of them.
And it turns out the way you ask the question really matters. The researchers found this simple but powerful little trick called prompt engineering. So instead of just giving the model the word dog, feeding it a whole phrase like a photo of a dog actually worked a lot better. This tiny change helps bridge the gap between simple dataset labels and the natural language Clip learned from, and it boosted its accuracy on ImageNet by another 1.3%.
Now, this all leads to what might be one of the most important findings from the research. The idea that this approach could create a much more robust AI, one that's way less likely to get fooled by simple real-world variations.
See, one of the biggest problems with standard AI is that the models can be super brittle. They learn to find these little patterns and correlations in their training data that help them get a high score. But a lot of these correlations are spurious. They're basically cheats that don't hold up in the real world. This creates what's called a robustness gap between how they do in the lab versus in real life.
And this chart just lays it all out. Because CLIP isn't overtrained on the specific quirks of one data set, it's way less vulnerable to these bogus correlations. You can see the performance drop for the standard model is huge, whereas the gap for CLIP is so much smaller. The paper found that CLIP actually shrinks this robustness gap by up to 75%. That's a huge deal.
All right, let's zoom out now and think about the bigger picture, what CLIP still isn't great at, and what its potential really is.
Look, CLIP isn't a silver bullet. It's actually pretty bad at some abstract tasks, like trying to count how many objects are in a picture. It also struggles with really fine-grained classification, telling the difference between car models or flower species. But its potential is just massive. This really represents a fundamental shift towards a more general-purpose AI that you can instruct and guide using natural language, kind of like you would with a person.
And that leaves us with one last and really crucial question to think about. This whole approach gets its incredible power by learning from a massive, unfiltered snapshot of the internet. But if an AI learns from our language and our pictures and our captions, what biases, what blind spots, what unintended lessons and associations is it going to inherit along the way? That's the real puzzle we'll have to solve as these powerful models become an even bigger part of our world.